High with a meaningful quote by John Dewey. Education is not preparation for life, education is life itself. With this, we'll solve one of the problem in Spur. The statement of the problem is as follows. A pair of mating spur gears has 20-degree full depth involute teeth of 8 mm module. The number of teeth on pinion is 20 and 5 kilowatt power will be transmitted at 1500 rpm. The transmission ratio is 5 to 2. Calculate the first one, number of teeth required for gear, second one, pitch circle diameters, third one, center to center distance, fourth one, torque on each shaft, fifth one, tangential force, sixth one, resultant force on each shaft, and seventh one, last one, forces acting between the meshing teeth. These are all the various unknowns we need to find, and definition or statement of the problem. Now we'll list out the given data of this particular problem. A pair of mating spur gear has 20-degree full depth involute, that is pressure angle he has given alpha, that is equal to 20-degree full depth involute, teeth of 8 mm module. So module M he has given 8 mm. The number of teeth on pinion is 20. So number of teeth on pinion Z1, that is equal to 20, and 5 kilowatt power will be transmitted. So power to be transmitted P is equal to 5 kilowatt, or in terms of watts, that is 5000 watts at 1500 rpm. Speed of the pinion N1 is equal to 1500 rpm. The transmission ratio is 5 to 2. Transmission ratio I is equal to 5 to 2, or 5 divided by 2, that is equal to 2.5. Calculate the first unknown, number of teeth required for gear, that is Z2 is equal to question mark, pitch circle diameters D1, that is equal to question mark, and D2, that is equal to question mark. Next, center to center distance A is equal to question mark, torque on each shaft T1, that is equal to MT1, that is equal to question mark, and T2, that is equal to MT2, that is equal to question mark. Next, tangential force, that is denoted by FT1, that is equal to question mark, as well as FT2 question mark. Resultant force on normal force on each shaft Fn is equal to question mark. Forces acting between meshing teeth are radial force Ft is equal, Fr is equal to question mark. So here suffix 1 and 2 indicates pinion and gear respectively. Soon after listing given data as well as what are the various unknowns we are supposed to find. Now we'll switch over to the solution. In that formula and solution, the first unknown, number of teeth required for gear Z2, that is equal to question mark. Here we know velocity ratio or transmission ratio or speed ratio I, that is given by the ratio N1 by N2, that is speed of driver to driven or speed of pinion to gear, that is equal to diameter of the gear to the diameter of the pinion, that is D2 by D1, that is equal to mz2 divided by mz1, module mm get cancels, and z is nothing but number of teeth on gear divided by number of teeth that on pinion. Now by substituting, we'll consider only one term, that is I is equal to Z2 by Z1. Here Z2 value we need to calculate. Z1, that is number of teeth on pinion he has given, that is 20. Velocity ratio I is equal to 2.5. By simplifying this, we are getting number of teeth on gear Z2 is equal to 50 teeth. Soon after getting the value, number of teeth on gear, that is 50 mm. Now we'll find out the second unknown what he asked, that is pitch circle diameters. So here gear and pinion have different diameters. D1, that is diameter of the pitch circle diameter of the pinion, and D2 is pitch circle diameter of the gear. So pitch circle of the diameter of pinion from by using fundamental equation D is equal to mz. So if you need pitch circle diameter pinion, then we supposed to replace the value of z by z1. So D1 is equal to mz1, and pitch circle diameter of the gear, that is D2, that is equal to m into z2. Now by substituting module value has given as 8, and number of teeth on pinion is 20 and gear is just now we calculated, that is 50. By substituting these two equations, we are getting pitch circle diameter of pinion D1 is equal to 8 into 20, that is equal to 160 mm, and D2 is equal to pitch circle diameter of the gear, that is equal to 8 into 50 or 8 5 are 40 into 10. So 400 mm. So D1 is equal to 160 and D2 is equal to 400 mm. The next unknown will be center to center distance, that is denoted by A, that is equal to question mark. By referring this particular figure, so here what I have drawn, that is for pinion and gear. So diameter of the pinion plus radius of the pinion plus radius of the gear, that is equal to center to center distance A, or diameter of the pinion plus diameter of the gear divided by 2. So that he has given in the equation number 12.3a, page number 203. A is equal to center distance, that is equal to z1 plus z2 by 2 into m, or d1 plus d2 by 2. So here pitch circle diameters, as now we calculated, d1 is equal to 160 and d2 is equal to 400. We'll substitute, we are getting the value center to center distance A is equal to 160 plus 400 divided by 2, or 560 divided by 2, or 280 mm. Next unknown will be torque on each shaft, that is denoted by T1 or MT suffix 1, that is equal to question mark, and T2, that is equal to MT2, that is equal to question mark. These two are the torque induced on pinion as well as gear. So now we know that power transmitted by the shaft, power P is equal to 2 pi nt by 60. Will modify the same for pinion and gear with the suffix as n1 and t1. P is equal to 2 pi n1 t1 divided by 60. So here speed of the pinion he has given 1500, and power to be transmitted he has given as 5 into 10 to the 3. So we'll substitute the same. By simplifying that, we are getting uh, torque on pinion shaft T1 is equal to MT1, that is equal to 31.83 Newton meter. If you are willing to get in terms of millimeters, then we need to multiply by 10 raised to 3. Similarly, by using another equation, P is equal to 2 pi N2 T2 divided by 60. So here N2 value is unknown, we'll call that as equation number 1. By using velocity ratio, I is equal to N1 by N2. Here velocity ratio has given 2.5, N1 value is 1500. We'll simplify that, 1500 divided by 2.5. We are getting speed of gear N2, that is equal to 600 rpm. Now by substituting this value in equation number 1, we are getting 5 into 10 to the 3, that is equal to 2 pi into 1500 600 T1 divided by 60. By simplifying that, we are getting the value T2, that is equal to MT2, that is equal to 79.58 Newton meter, or 79.58 into 10 to the 3 Newton millimeters. Now we'll evaluate the tangential force. Here we know that tangential force is going to exert by both pinion as well as gear. Generally its value is same. We'll check whether we are getting the same value or not. So now by using equation number 12.8a, page 206, here I am referring Balvi Reddy and Mahadevan data handbook, design data handbook, version or edition 4. So in that equation number 12.8a, page number 206, tangential force Ft is equal to 2 m suffix t divided by d. So we'll modify that for pinion and gear as Ft1, that is equal to mt1 divided by d1, and Ft2, that is equal to mt2 divided by d2. By substituting the values of mt1 and d1, mt2 and d2, we are getting Ft1 is equal to 2 into 31.83 into 10 to the 3 divided by 160. So Ft1 is equal to 397.87 Newton, and for gear Ft2, that is equal to mt2 divided by d2, that is 2 into mt2 is 79.58 into 10 to the 3, d2 is the diameter of the gear, pitch circle diameter of the gear, that is 400. So we are getting the value Ft2, tangential force on gear, that is equal to 297.9 Newton. So here these two are almost same. We'll go for the conclusion, that is Ft, tangential force, as 397.9 Newton. Next unknown will be resultant force or normal force for on each shaft, that is Fn. So by using equation number 12.8c in page number 206, equation is F suffix n is equal to 2 mt divided by d2 cos alpha, where m suffix t value should be maximum. That is by referring mt1 and mt2, mt2 value is higher, that is 79.58 into 10 to the 3. We'll substitute these values in above equation. We are getting Fn is equal to 2 into mt2, that is 79.58 into 10 to the 3 divided by d2, that is 400 into cos alpha. Alpha is nothing but pressure angle, that is 20 degree. By simplifying this, we are getting the value Fn, normal force or resultant force, that is equal to 423.44 Newton. Now, the final unknown, that is the forces acting between a meshing teeth or a radial force Fr, that is equal to, by using equation number 12.8b, page number 206, F suffix t is equal to, sorry, F suffix r is equal to F suffix t into tan alpha, where F suffix t is nothing but tangential force into tan alpha. Alpha is nothing but pressure angle. So we'll substitute the value. F suffix r is equal to F suffix t, that is 397.9 into tan alpha, that is tan 20. By simplifying this, we are getting a value, that is forces acting between meshing teeth or a radial force Fr, that is equal to 144.82 Newton. So now with this we came to the conclusion of this particular problem solution. All unknowns we have calculated. Yes, thank you. Hi, with a meaningful quote by John